Hello and welcome everyone. I'm your host Stefan Burns, geologist, geophysicist, space weather guy, cosmic bro, someone who's interested in what's happening on the planet. And well, there's been a lot of strange things happening here on Earth over just the past 12 months. You may recall that we had a massive earthquake off the coast of Kamchatka, Russia. That's in the deep ocean, and there have been some interesting things occurring in the deep ocean over the past months, years, decades. A lot of new discoveries that we have recently stumbled upon. For example, up in the high Arctic, because now the sea ice is thinning, we're finally able to do bathymetry of the ocean floor there, and well, we've discovered some very unusual things, potential supervolcanoes, structures that we don't understand, and just in general, the advent of global bathymetry data, though most of it is extremely low resolution, has allowed us to discover things that perhaps we're not supposed to know. And there has even been some intentional obfuscation of things found. Some of you may be aware of this weird structure found off the coast of Malibu, California, and it showed almost like it looked like some sort of underwater base or something. And then now if you look in Google Earth, it's totally blurred out. So we're going to talk about that. We're going to talk about a lot of unusual things from the deep abyss, these structures, some of them looking like just unnatural in general, like disc on the bottom of the seafloor that apparently are moving somehow. Effectively, this is a collection of things that I found on Google Earth that is not comprehensive, that just really seem odd and bizarre to me and warrant further investigation. And so that is what we're going to do in today's video. We are going to explore into the deep abyss, and after we look through some of these unusual oddities, we are going to also perform a meditation, because where science fails, perhaps our ability to send our consciousness to these locations will help us to perhaps glean some insight. And so collectively, we can do that, and then people can share their experiences during the meditation in the comments to the video, and perhaps we'll discover a few things together live right now. So without further ado, we are going to get right into it. Here we have Google Earth, and you see that our Earth is covered with about 70% oceans. It's mostly ocean, right? This is the Pacific Ocean. If you look at it a certain way, it's all just one big blue marble. It's really quite fascinating. The other 30% is continents, and there's some interesting ideas as to the continents and the oceans and more. We've explored all that on the channel. So let us start with the one that most people know about, which is this strange underwater structure off the coast of Malibu. So here we have California. I mean, you saw me to zoom in, but here we have California. Here's Los Angeles. We have Malibu there. We just had the big Malibu fires, which was tragic. But if you go to Google Earth now, you won't see anything. You're never going to find this really or think it's notable if you get here, because this is what it looks like. And a lot of Google Earth looks like this. We don't have global coverage. Some places have a lot of high resolution data. Actually, this is kind of interesting. Look at this square. What the heck is this? What is this? I've never seen this before. You guys seen this? I mean, this looks like a data artifact or something, but I don't know. That's strange. I'm telling you, man, there's weird things. If you explore Google Earth, there's too much data for them to like hide it all. That's really what it is. And so going back, we'll go back to the square, I think, but to go here, basically people started speculating that this was like an underwater base. And let me show you what it looked like before they scrubbed it, okay? So you can really clearly see this. So here's what it looked like before they scrubbed it from Google Earth. And you see these pillars, they look like supports or something, flat top, and the idea, the conspiracy, whatever you want to call it, is that this was a base for aliens and that there were underwater submersible vehicles like USO that were coming out of this, and that would be their location. And to add even more into this, that this was located here in Malibu because that's where a lot of the rich and elite are, and Hollywood and everything. So it is a convenient location next to Los Angeles to have this underwater alien base. I don't stand by any of those claims. I don't endorse them. I don't say they're totally nutso either. I just simply am just presenting that this is what it used to look like on Google Earth, and now we can see what it looks like right here. And if we kind of zoom in like this, you see it's just totally been blurred arbitrarily. Here's the thing. I have worked in the marine seismic industry, at least for a company that did a lot of marine seismic. And what they do, in addition to a lot of marine seismic for oil and gas exploration and more, studying the subsurface, is they also do a lot of bathymetry data collection. And these locations here, there's been a tremendous amount of research done off the coast of California. You have San Diego, you have Scripps Institute of Oceanography here, and a lot of research is launched from Southern California out into the Pacific and beyond. And so this area, as you can see, is extremely well mapped in high detail, some parts more so. If there's a specific target that they're looking at, you'll get high resolution data. Here's our square again. What the heck is this? But in general, as you can see, this whole area, oh, this must be like a data thing, because here we're getting square angles as well. This is weird. Okay, it must be how they layer in the data. I've just never seen that before. It's like showing up just now. But here you see it's super high res, and then if you go over here, all of a sudden you see that they intentionally blurred this whole section, whereas they didn't have that blurred before. So very bizarre. Why? That's a good question. It's a very good question. I don't know why. This is interesting too. What the heck is this? See, there's so many weird things here. This looks like a data error. I don't know. I don't know what's happening here. This is weird. It looks like paw prints going across the surface. But that is whatever the heck that is, geologic feature or something like artificial or made, I don't know. I mean, if I had to put my chips down, I would say it was natural. But why did they hide it intentionally? I mean, it's not like a few people online saying it's aliens is going to cause a societal revolt, all right? What they're doing with the government is way worse than that to cause a societal revolt, and it hasn't happened yet. So why would they go out of their way to scrub this effectively? Unless they're like, oh, we're catching it early before people really catch on, let's hide it, and now unless people talk about it, it's not going to be in the public knowledge sphere. So that's weird. We have some other strange objects, and we're going to talk about volcanoes too, because here, we often discuss volcanic activity on the Earth, and we look at volcanoes on the surface. For example, we have like Lassen and Shasta and Mount Rainier. Here's a whole bunch of volcanoes on the west coast of the United States. We talk about volcanic activity quite a lot on the channel. One of the largest volcanoes on the planet, Hawaii. Right, these are all visible surface expressions of volcanic activity. 70% of the Earth is covered by ocean. Most of the volcanism that is occurring globally is hidden from us. We do not know what is happening for most of the volcanic activity. So those longer rhythm trends of increased pulses of volcanic activity and then decreases, we really aren't tracking that in any good, reasonable way. I mean, there's definitely a lot of scientists out there working at it, but there's just such a vast ocean, so much of it unexplored. It's only like 5% explored, they say. We really don't know what's happening at depth. And you see, look at all these seamounts, right? Look, this is a lot of coral reefs and stuff, but there's a tremendous amount of volcanic activity across not just like the spreading centers and mid-ocean ridges and subduction zones and such, where you get these, these are all, a lot of these are volcanoes here at subduction zones, or a classic example would be down here, Mariana Trench. We'll talk about that. You get these volcanoes coming up here, for example, right? Some of them are very active, some less so, but you get these subduction arcs and these volcanic arcs on the back end. You actually have two of them right here. But there's a lot of volcanism in areas that you simply are like, why is that there? Doesn't really make sense. We have axial seamount. It is kind of on a spreading center, but this is a shield volcano underwater. It's been very active with earthquake activity. And look at all the other volcanoes nearby, right? All these seamounts, volcanoes, you see a bunch of unusual features in these areas. Some of these being quite large. Look at this, right? So there's a lot of weird stuff. Now, just nearby to this, we have the disk. This is what I'm calling it. And you may be aware of this. It's not like I'm the first person to ever talk about this. But here we see this round-shaped, disc-shaped structure on the seafloor. And it's pretty large. Let's check it out. We can measure it. So let's go across right here. That's saying it's 4 kilometers, 4,000 meters. And if we switch that to miles for the Americans, it's 2.5 miles. So 4 kilometers, 2.5 miles across. If you go the other direction, it's 2 miles across. So this is a big structure. Now, in and of itself, it's odd because it's symmetrical. But if you notice, it has this pattern, this track connected to it. And on this side of it, there's no path, but behind it, you see that there's this clear path that it's like moving across the seafloor. So that's what it appears to be doing. It appears to be moving across the seafloor, and at what rate and speed, we don't know. But if you zoom in just here, you think it's pretty small, but if you zoom out, you notice that this track continues further along, and you notice where they go in and out of high depth imagery. So you're not seeing the track with the super low res bathymetry data because it's too little relief from the seafloor to this depression. But you would see, for example, a little bulge with the seamount. Here we see it in much better detail because they got better data. Why did they get data out here in such high quality? I don't know. It's interesting to think of for that reason as well. But we see this track go in and out. We can basically follow it for quite a while. See, it goes all the way through here because we pick it up again. Unlikely that it just peters out. And then now that you're in this area, you'll see that there's other tracks nearby. So no one really knows how this works because this is 2 miles across. Maybe some of you have heard about the moving stones in Death Valley, where there's this basically basin, and you see these stones on the ground. There's tracks behind them, and people didn't really know how they were moving. I think they figured it out. It was every now and then when it freezes, they move just a little bit, but over hundreds of years, they create these long tracks. It's something like that. I don't think it was wind related. It was like this freeze-thaw nudging of these things forward. But that's like a stone that you could pick up in your hand or something. So for a force like that, or the wind, if it is the wind, to act upon it, makes sense. It's at like a realistic scale. This structure here, which no one knows, like A, what it is, or why it's doing this, recently discovered, right? Like we didn't know about this until we got the bathymetry data, which is all in the past 50 years maximum. It's not like we've known about this for hundreds of years. How does that thing move across the seafloor? I don't know. Here we have more tracks, and they're really actually all over, right? Here we see some more right here. So what is this thing? Are there more of them? Maybe we're only really seeing this one because we got this super high resolution pass over it, but there are perhaps others in these low resolution areas. We don't know. It's straight. I mean, you can even see it really zoomed out here. If we measure this really quick, just to get a sense of scale, we're looking at 150 miles here. So this is pretty zoomed out, and we can see this sinusoidal shape squiggling across the bottom of the ocean in the deep abyss. I mean, let's zoom out again. This is like deep ocean right here. Maybe it's not as deep as the Mariana Trench, right, which is very deep, but we're way off the continental shelf now. We are in the deep, deep, deep ocean, the abyssal zone. And no one knows what that is. Now, it's not the only disk that we know of. There's probably more than just these two, but let me show you the other one that is very bizarre. And it's off the coast of South America. So the other one's off the coast of North America. Here, we have that strange underwater structure, whatever it is, that was scrubbed intentionally from Google Maps and Google imagery here. And then you go further south and we have this thing. What the heck is this? Here we have another disk. Now we don't have this thing leaving a track on the ocean floor, but this is quite strange. If we click here, this one is about the same size. So it's actually twice as large, because the other one was 4 kilometers. This is 4.5 miles across. So this thing's about twice the size as the other one, but it's not an order of magnitude bigger or smaller. It's roughly in that zone. So what is this thing? I mean, it's like perfectly symmetrical. What geologic process could create that? Because the standard model of geology is that you have the mid-ocean ridge, which we see, there's actually quite a lot of activity here, but, oh, that's a different thing. I'll talk about that later. Here we have a mid-ocean ridge, okay? This is where the continental plate is being generated, like this, and then it spreads out. Well, I mean, yeah, eventually over time you're going to get some abnormalities, and that's the thing. You also have volcanism, which is poking up from below and causing different structures to emerge. Or, for example, we have the Galapagos. There's a hot spot there, so the oceanic crust is moving, and you have this normal upwelling from the mantle coming up there, creating this land and building a lot of geologic structure. But it's not too busy in this area. Actually, if you look around, I mean, it's a lot busier in other zones. Here's a way busy, right? If we're talking about these sort of dynamics. Over here, it's a lot busier. We see these submerged seamounds and ridges now that lead back to Easter Island here, because that's also part of a hotspot system. We'll talk about that. But this is in a pretty quiet area. So like, what is this? This is very bizarre. I don't have an explanation for that. Now, a lot of people think that these are USOs, underwater, I guess it's underwater submersible object or unidentified submersible object that go underwater. So instead of an unidentified flying object, this is like one that goes underwater. And tons of people talk about how there are these transmedium vehicles that can go out to space and then also go into the ocean and go down. And some of the ideas is that you have aliens not living on the surface, is that in fact you have aliens living at the bottom of the ocean. Because they're like, the humans don't have the technology, they're not going to bother us, we're fine, and then this entire thing, in fact, is a UFO and could just come right up. Alien sub base is one of the ideas, and honestly, it's not like I'm going to immediately dismiss it, because it's very odd. And if we were to do bathymetry on this, right, and the aliens are there, and then we do bathymetry on it, the best thing that they could do is to not move the base, because then if we rescanned it and it's gone, then it'd be like, wait, what? So it's kind of locked in position based off of that until they were to maybe like, oh, we'll just wait for the cataclysm to wipe them out. Then they'll forget all about us. But It's very bizarre. I don't know what that is, and the fact that we have this other one here as well in North America, the disk, apparently moving across the seafloor. That's like the big mystery here with this one, is how is it moving across the seafloor? And I think it's too much of a coincidence for this channel here to be the same width as this structure slash object. Because if it was totally different width, like twice the width of this, I'd be like, okay, maybe it's just random that this is in the middle of that, but you have it like moving across. I think that is the best explanation, but how? I don't know. I mean, here's another fairly circular object here. I'm telling you, they're all over. If you start to look, I mean, these oddities are all, I mean, totally empty, flat, and then you get these strange structures. A lot of it's volcanic. You have to keep in mind, probably 99% of this is volcanic in terms of just looking on Google Earth and finding things. But not everything, not everything. And I think it's very interesting that we have this kind of alignment here of this object and this object being on either side of this underwater structure that was geologic or otherwise, that they've intentionally hid. Find that very bizarre. So let us move on to a few other things. Just a couple other oddities I want to show you. This is bizarre. We really don't know what the deal is here. But to start, we'll talk about Gokul Caldera and Gokul Ridge. Now, some of you have been wanting me to make an update on Gokul Ridge. You can consider this that update. There hasn't been anything super crazy earthquake activity wise as it relates to this spreading center. For context, this is the northern part of the world, right? Way up in the Arctic. We just recently discovered under the ice this spreading center. It is the slowest spreading center on Earth. So the plates are diverging here incredibly slowly at about rates of 1 centimeter per year, whereas other spreading centers are 2, 3, 4, 5 centimeters per year. And also even going down to 6 millimeters per year. So we started to map out Gokul Ridge over the past 50 years or so. We started to do geologic data collection, actually taking submersibles down and geochemical analysis and all this cool stuff that they do. We discovered this caldera in the 1990s. It was officially published effectively in 1999. So this is a recent discovery. And let's give you a sense of scale. So we'll measure this, okay? So here, not that. Here we have our measure tool, and it is about 62 miles across. It's about 100 kilometers. And I believe it's about 25 miles wide. Let me get that. 30 miles wide. So this is a huge underwater caldera. You can see that it's deeper. It's quite a bit deeper than the surrounding seafloor. We can see that here. Here we see a graphic I made covering Gokul Caldera. I have an entire hour-long video on the Gokul supervolcano system because that's what we think created this caldera. I can turn myself off briefly. Gokul Caldera, it is a massive caldera in the seafloor at the very end of the Gokul Ridge spreading center. And tectonic forces, volcanic forces, or an impact event are needed to create a basin this large. Given the available evidence, a big supervolcano eruption is the best explanation. And I've covered this in depth on the channel multiple times because I think this is a very important geologic system to be aware of, because if you go back to Google Earth, this is the uppermost part of the mid-Atlantic spreading center. It goes all the way from the Arctic Ocean, zippers down past Europe and North America, then past South America and Africa, right? We see this. This is the mid-Atlantic spreading ridge. And then it goes all the way down here to Antarctica until finally we get to this triple junction there with the South American plate, Antarctic plate, African plate. So the Earth, like nearly half the Earth has this zipper going across of it. And this is obviously very important. And then on the other side, we have the Pacific plate, which is the largest plate. So it's very interesting dynamics to think about. Well, at the end of this, it slows down, but you also know that over here it's spreading quick. So there's this discontinuity, you could say. And then we go to the very end of the spreading center, and what do we get? We get a giant caldera. Well, about 1.1 million years ago, the evidence suggests that there was a massive volcanic eruption here on a scale unlike, it's basically a supervolcano eruption on a scale beyond almost every other volcanic eruption on Earth. Let me show you what that looks like. I have a volcano comparison graphic here. This is the size difference. So we have Gokul caldera, estimated 3,000 cubic kilometers of material 1.1 million years ago. Last Yellowstone eruption, 600,000 years ago, only 1,000 cubic kilometers of dry rock equivalent blasted out. Then we have Mount Tambora, 1815. We have Pinatubo, Mount St. Helens. So the size of the circle equates to the volume of the ejecta. Massive difference. This is a huge, huge, huge event that occurred, and we still have active activity there. So if you go back, we had in 1999, I believe it is, a very significant earthquake swarm on Gokul Ridge, defined by a whole bunch of magnitude 5s, and even going up to 5.5 and I think magnitude 6. And magnitude 5 plus earthquakes on mid-ocean ridges, they occur, they're not that common. Magnitude 5.5 and magnitude 6 or greater earthquakes are very uncommon. So if you're seeing anything at magnitude 6 or greater on a mid-ocean ridge, you got to pay attention. Well, we had this flurry of earthquakes on Gokul Ridge, and then they went there with their rovers, and they discovered three new volcanoes. And I'm not sure I can find them exactly where they are. I don't know why. This is weird. Why is that suddenly up here? Does it go away? Okay, it does. Here's some small volcanoes right there. But they discovered 3 new volcanoes, which were Thor, Loki, and Odin. And they actually found pyroclastic glass ejecta from those volcanic eruptions. So the earthquakes were because of the volcanic eruptions. And even though this is under like 4 kilometers of water, it was still powerful enough, these eruptions, to generate pyroclastic flows at depth and going quite a ways out and forming pyroclastic glass. So what they did is they did a chemical analysis on that, and turns out the CO2 ratio is about 10 times higher than it is in normal mid-ocean ridge basalts. So normally it's about 1.5%. Here it's pegged at about 13.5%, which means it's very volatile. It has a high volatile percentage, and when that depressurizes, it makes it extremely explosive, like unbelievably explosive. So if you get that depressurization, you can have massive, massive events here. So what it seems is that the energy that is active at this part of the globe, because every part of the globe has energy to it, whether it's subduction or plate being generated, there's always some sort of dynamic. The energy here is not being fully dissipated. You know, the convection coming up from the mantle is not being fully dissipated by the spreading rate, because the spreading rate is very low. And so instead, it appears that these really large magma chambers get built and then sometimes explode decompressively. And this is one result of that, Gokul supervolcano caldera. That's the best explanation, because we have the volcanic evidence, the earthquake evidence, the geochemical evidence, and we also see just this massive caldera in the ocean floor. And in fact, the crust is so thin here. This part of the globe, the oceanic crust, is exceedingly thin, so thin that they've been able to retrieve samples of minerals in certain rocks that you would only expect to see from the mantle. So parts of the mantle are even actually being exposed here at the surface, at the border of the ocean water, because the oceanic crust is just so thin. It's really quite incredible. Now, so that's strange in and of itself. We talked about that quite a bit on the channel. Here we have the other end of Gokul Ridge, because Gokul Ridge starts at Svalbard and then ends at Gokul Caldera. At the other side of Gokul Ridge, we have the Molloy Deep, which is one of the deepest points in the world's oceans. And it goes down, what, 5,569 meters? As you can see, it looks very similar to Gokul Supervolcano Caldera, right? If you just look at these two. I mean, this is wider and flatter and larger, but it's basically a big depression in the oceanic crust, which is already very thin here. What is creating that? That's the big question that no one really has a good answer for. For Gokul Supervolcano, we have that as the explanation. For Molloy Deep, we really don't know. I mean, we kind of do. Here we can check out some data from Norway, because this is Norway's deepest hole, as they call it. And here we see some 3D topographic data, so really cool bathymetry data here. It goes down. This is not in the Molloy Deep. This is their tallest mountain that they layered into this graphic to give you a sense of scale. I guess if you're Norwegian, you understand that. But it just basically goes straight down. This is a volcano. So right next to this massive depression, you have this massive increase in the elevation due to this volcano right there. So there's a huge height difference between them. It's almost like a waveform. You get an up and then you get a down. They seem to be part of the same system, where this upwelling, perhaps, you know, there's clearly subsidence here of some sort. This subsidence is pulling things down, and then this upwelling is occurring right next to it. It's almost like a vortex like this. Very, very bizarre. And I think it's very, very strange that it is exactly at the other end of the Gokul Ridge system, because this is the Gokul Ridge system, and then once you get to here, you're basically back to the Mid-Atlantic Ridge. I could be wrong. I think if this is the Mid-Atlantic, this is then a different spreading ridge. I don't think Gokul Ridge goes all the way to Iceland. I'm pretty sure it's just the Svalbard to Gokul Calderas segment. So having two of those next to each other is very strange. Remember, most of the Earth's volcanism is occurring under the oceans, just because that is where most of the surface area is oceanic crust. And so, you know, what's happening in the deep Earth doesn't really care too much about what's happening on the surface. It's going to happen there anyways. And if oceanic crust happens to be on top of it, then and it expresses itself, then that's where the remnant is going to be left. So I say that because here, I was zooming around when I was getting ready to make this video. I saw this. I don't know what this is. I'm sure I could find more of these, but this looks very similar to Gokul Supervolcano Caldera, right? Now it looks like it's part of this larger kind of geologic structure and system coming off the coast of Australia here, which is a little bizarre. But it also looks kind of like its own feature, to be honest. And here's where things get strange with this thing. You know, I'm just pointing out an oddity for you. You can measure across. It's about 25 miles across. That was the same width as Gokul Caldera. And if we measure this way, let's go to about here. I think that's a good spot to go. That's about 50 miles across. So not as big as Gokul Caldera, but pretty darn close. The dimensions are nearly the same. It's not, again, like an order of magnitude different. So that's strange. Is that a remnant of another large volcanic eruption? Like, clearly it hasn't been mapped in that much detail, or else we would have higher resolution data. Unless, you know, they're hiding it. But I don't think that's the case in this instance. So it's one of these things of we just haven't explored the ocean. We really just don't know what's happening with most of the ocean, and therefore with most of the geology here on the planet. You know, we think we really know the planet geologically because of everything that we see with the continents, but I bet if if everyone somehow across the globe came to an agreement that, okay, we're going to do massive ocean-wide expeditions for the next 100 years, and it became like a major industry of research, let's say. Like it became one of our, just as much a focus as space exploration, let's say. Let's say our deep ocean exploration became as much of an interest as space exploration. In 100 years' time, our understanding of Earth's geology would be so different that it would be mind-blowing. I would stand by that 100%, because this is where most of the secrets are hidden. That is just an intuition, but I mean, it also just some of this very simple math makes sense. Just the numbers of surface area and more. Now, like a point to that is here we have the Mariana Trench, the deepest point on Earth, because we have the subduction of the Pacific plate underneath, I think this is the Philippine Sea plate, but don't quote me on that, but under a different plate here. So the Pacific plate is subducting underneath this oceanic crust like this. And what happens, you can map this out. We get earthquakes at various depths, 0 to 150 kilometers, 150 kilometers to 300 kilometers is a zone where we get very few earthquakes. And then we get more earthquakes again going from 300 to 600 kilometers. Well, what we observe with our earthquakes is that you get this, so I'm going to go head on for you, okay? You get this plate subducting underneath, and it doesn't go like this. It actually eventually goes straight down. It's fascinating. It goes straight down, and we track that with earthquakes. So as we built out our global seismic network, we were able to start to visualize these dynamics because these earthquakes are occurring in that subducted slab. That's the best theory that we have right now. We have the earthquake observational data. The exact structure is still up for debate, but most people have coalesced behind the subduction of the oceanic crust underneath because we see it being generated at the mid-ocean ridges, and we can track this with GNSS. So I personally subscribe to that, but I'm also open-minded. So you have, this is the deepest trench. This is going straight down, folks, okay? What's on the exact opposite side of the Mariana Trench? Well, let's find out. This is interesting. Here we have our antipode map, and I put in Guam because Guam is right in the Mariana Trench, okay? Lovely island if you've ever been there. And if we go to the antipode for Guam, you see that it's right there off the coast of South America, Brazil. That is exactly where Earth's magnetic field anomaly is. The South Atlantic anomaly is centered exactly right there. And let me show you that directly because it really is, it's quite wild. And I think it shows that the geology of the Earth is very important. For example, plate tectonics is very important in determining these other geophysical dynamics of the Earth, for example, the magnetic field. So the South Atlantic anomaly is where Earth's magnetic field is weakening the fastest at this moment in time, very, very quickly. So here we have the South Atlantic anomaly. This is in 2014. It has grown since, and it has also weakened since. But look at this location. It's right here. It is extending out towards the southern part of Africa. But this is that antipode for Guam. And Guam's actually a little bit to the south of the Mariana Trench. So let me show you that really quick, because the further north you go, then the further south the antipode will be. So if we go back here really quick, we see Guam is here at the bottom of this trench, okay? So if our antipode is to the north, well, if we go and get the Mariana Trench exactly in the center, maybe there's an island there. Guguan, I'm not sure that any of those will pop up on that app. But just effectively, now that you understand that, you know, go up a little bit on this, and that's going to shift even further down, and that takes us again right to the South Atlantic anomaly. So we see also how these deep earth and deep ocean structures potentially have a very profound influence on Earth geophysical dynamics. How long has the South Atlantic anomaly been here for? Is there some reason why that's manifesting? I mean, that's the other side of the globe. So it's the other side of the the core, the outer liquid core, and also the inner core. Maybe it's just a coincidence. I mean, there's got to be some part of the Earth that is opposite the South Atlantic anomaly. But here's where you have to kind of put your mind, in my opinion, is that the South Atlantic anomaly is the biggest magnetic anomaly on Earth. So it's very strange and special. It's not mundane. The Mariana Trench is the deepest point on Earth. It's very strange. It's very special. It's not mundane. They're both highly significant in their own way. The fact that they're exactly opposite each other is quite strange. So these are just a few of the things that you can kind of contemplate and think about when you start to explore this. And there's definitely a whole lot more. Here's another one. Another one of these strange caldera structures on Google Earth. And again, another one I just found when I was zooming around getting ready for this video. Here we have the strange disk here, the 4-mile across disk off the coast of South America. And what's strange about this one is about how well it's been mapped. Look at the resolution on this. If you look nearby, everything else is super low res, okay? And we get some, and the difference here, that's also showing the difference in resolution because these sonar beams are only so wide. So what ships often do is they will just leave it on when they're going out to collect data because it's better to collect data than no data, though they may have an area of interest. So let's say they launch from, I don't know, we're just going to use the Galapagos, okay? Let's say they launched their ship from the Galapagos. See how there's these straight lines? That's because they left their sonar on, and here's a good example. And then here they went and mapped it in extreme detail because they want to understand the geology. And then they'll leave it on as they maybe go off to the next location. So you can see those tracks on Google Earth. Here's another clear example of that, right? But this clearly then was an object of interest because they traveled to it and mapped it in heavy detail. And it's strange. I mean, let's measure it. Let's see how big this guy is. It doesn't look exactly like Gokul Caldera or the other one, but it's similar. I mean, this is 45 miles across in length. And then if you go by width, 25 miles. They're all about the same size. I mean, there's a pattern and a trend here. And if that is the case, it looks like if these are all due to supervolcano eruptions, then there's a bunch of these. And maybe these are one-off supervolcanoes where you get this magma caldera to accumulate and then just explode like a pimple, and then that's it, and it doesn't come back. Maybe that's what happens. And then for systems like Gokul Ridge, it is more continuous because you do have this active spreading center across geologic time, millions of years. But in this other location here, perhaps you just get a one-off, some flow of energy through the mantle, created this decompression melting near the surface that eventually just goes boom. Because there's nothing really near this thing. I mean, you have the supervolcano nearby not supervolcano, the hot spot for Easter Island nearby. I mean, you see the track of that across, but it is kind of isolated by itself there. So there's a lot of strange things in the ocean. This is honestly a very small sampling of them. I didn't want this video to drag out too long. So yeah, I'm going to be back with more videos on the deep abyss. It's one of my favorite topics and interests. And I like making videos on it. And in general, if you'd like to stay up to date with what is happening with the Earth, this is earthquakes, volcanic activity, geomagnetic storms, severe weather, all that stuff, solar activity, planetary resonances, comets and interstellar factors, cosmic forces, all that. I'm your guy, present videos almost daily. I'm looking at things from all angles, and while I may be a master of none, I think by being interdisciplinary, it actually helps to give a better picture because you're not going to, there could be the answer that you need in this domain and this domain, and then if you put the three together, your answer emerges, or at least the new insight emerges. So that is really what's about here on the channel. And to really prove that, we are now going to do a meditation, a deep abyss meditation to just maybe kind of learn more about these structures or just what secrets the Earth is holding. You know, we are connected to the Earth in resonance. We have the same brainwaves as the Schumann resonances, Earth's naturally resonant energy fields. And when you go into meditation, you actually cultivate higher power Schumann resonances in your brain. This is 7.8 hertz. This is 14 hertz. Your brain waves become coherent in structure and they layer in certain ways. And so meditation is a great way to enter into these states of knowledge acquisition. And some of the best ideas and insights that have come to people have been in meditation and or in dreams. So maybe some of you or us collectively, we can learn a little bit more about what's happening in the deep oceans. So let me grab my singing bowl and we will get started shortly. I recommend you find a comfortable seated position and start to regulate your breathing, and we will get into it. Take a deep breath. Now we journey not only to the ocean, but to the deep abyss. Close your eyes, relax, and just start by visualizing waves on the surface. Our mind is like the ocean. We are normally at the surface, caught in the waves. Sometimes we find moments of stillness. The waves go away. Other times the storm rages. But this is all the surface of the mind. And the mind goes much deeper. So now we want to go below the waves. Start to swim down. And just sink, just relax, float, fall back. You are protected. You have all the resources you need, air, oxygen. Mother Earth is holding you. You are in the womb of the planet, the oceans, where most of life lives. And just start to sink deeper and deeper. You can feel the currents. At the surface there are waves. Deeper below there are these currents, emotional currents, psychological currents. Sometimes quite strong, sometimes not so much. The light is fading, it's dimming, it's growing darker. We continue to sink into darkness. currents are growing quiet, still, disappearing. And soon you will feel no sensation whatsoever. Just darkness. We are now in a void space on the planet. We have reached the deep abyss. What do you feel? What do you sense in the deep abyss? Just observe. Widen your senses. Expand your consciousness. What are you noticing? Enveloped in the waters. What do you feel? And now that you are here, if you feel comfortable and called, you can ask Mother Earth questions. About the deep abyss, her secrets, the stories, the history. Open yourself up to this ancient knowledge. What lost ancient technologies are hidden in the deep abyss? What geologic cataclysms occurred in the deep abyss? What life, organisms, and perhaps even aliens have lived and or live in the deep abyss? begin to rise, thankful for our safe journey to these deep and dark places where few ever venture or explore. We slowly rise to the surface. Darkness becomes gray, and gray slowly becomes light as the surface of the ocean comes once again into view. We emerge from the subconscious back to the conscious mind, recognizing now that the waves on the surface are but a small part of the vast ocean that exists, and that all parts of the ocean and our mind are accessible to us. We give our thanks. We ask for blessing and protection from Earth, the Sun, Solar System, Universe, God. Namaste. Thank you all so much for joining me. If you did the meditation and you had some interesting insights, I would definitely recommend that you pause the video now and write that down while it is fresh. And if you feel called to then share that on the channel via the comment section, because this is one of the best ways we can learn about the deep abyss, because the cost of mapping the ocean floor and exploring it actively is astronomical. So I think the best way for us to explore it, especially us the common people, is via the direction of our consciousness. So thank you all so much for watching, everyone. Again, I've been your host, Stefan Burns, wishing each and every single one of you well. Please subscribe to stay up to date with what is happening. I'll be your guy. I make videos almost daily. Would love to see you around. Welcome to 2026. A lot's going to be happening this year, and hopefully we have a great time with it. So I'll be back with more very soon. And until then, I wish you a great day. Thanks so much.